Hello, my name is Dr. Ed Carlson, Professor of Anatomy and Cell Biology at the University of North Dakota School of Medicine and Health Sciences. It is my privilege to serve as interviewer of Dr. Robert O. Kelley, who has been selected by the American Association of Anatomists for its Living History project. This project documents the professional lives of prominent anatomists by creating a recorded interview discussing their lives and careers in an effort to preserve their memories for future generations. Dr. Kelley, I am honored to have the opportunity to spend a little time with you and to ask a few questions that hopefully will allow you to enlighten us about your career as an anatomist, scientist, senior administrator, and consummate academician. Although we've known each other for many years and I am very familiar with your career in anatomy, others may not be able to relate quite as well to what you've accomplished in your years in the morphological sciences, and particularly your meteoric rise through the administrative ranks to now president of the University of North Dakota. So why don't we start by having you share a little information about your early life and those influences, both parents, other people, books, and so forth, that contributed to your career development. And a first question might be, did you have any early interest in science?
Well, Ed, I have to say thanks for that very generous introduction. That was very kind, and I appreciate that. You and I have known each other for many, many years, and to sit here with you and to have this interview experience is a real privilege. So thank you for taking the time to help with this.
Sure.
Oh, you know, I remember back, even as a boy, becoming interested in natural things. Just how do natural processes work? I remember taking hikes with park rangers and being fascinated by biological diversity. I didn't know then that it was diversity. I just knew that there were lots of different kinds of insects and different birds. And I guess that fascination stayed with me, wanting to understand biological function, how it related to biological structure. Famous architect Sullivan once said that form follows function. And I think that had sort of an innate curiosity for me, even as a boy. I was curious how function and structure connected. And that has been a curiosity that's lasted me to the present day.
And was this as early as elementary school, for example?
Oh, I think it was. I just remember walks with my folks on hikes down in New Mexico where I grew up. Dad loved to go to the national parks. Dad was a librarian. We would always travel to the American Library Association meetings. We'd camp along the way and we'd connect with the national parks. It was just a wonderful experience growing up, being exposed to natural things.
So how did you become interested in anatomy as it's broadly defined?
Well, I think again, the form follows function statement. I have a very peculiar memory of going to lunch one day with Mom and Dad, and as I was waiting for them to pay the bill, I was looking at the books in the lobby of this restaurant. And there was a book on ornithology, birds. And as I opened the book, I noticed that it had the various parts of birds labeled. It was a diagram. And I thought, this is kind of interesting. I didn't realize that birds' parts had names. And I think that was the first real awareness that I had of becoming interested in the structure of biological things, living things. And that fascination grows if you start looking at the language of anatomy, if you start trying to understand the rationale, the reasons for anatomical structural names. It becomes quite a fascination. It's also a fascination with geography. I've always enjoyed travel and relationships. Where is north versus a city, Paris, Tokyo? What's north of that city? Well, anatomy is the same way. What's superior? What's inferior? What's lateral? What's medial? I just think it kind of came naturally to me, and the fascination was lifelong.
Well, the language that you use, of course, is the language of the anatomist, and we're both very familiar with lateral, medial, and superior and inferior. And the concept of function following form is one that we certainly share. Dr. Kelley, where did you go to graduate school, and did you have any particularly memorable experiences during your graduate study that influenced you specifically?
Well, I went to the University of California, Berkeley, back in the latter part of the 60s. I think the years that I spent at Berkeley were some of the most formative years of my not only professional life, but life. Many, many wonderful and still very intense moments that I shared with a variety of people at Berkeley. I was privileged to study in Richard Aiken's laboratory. He became my major professor. I started out working for him. I had been kind of fascinated by electron images, and Dick was doing electron microscopy. I needed a job my first year of graduate school. I was a TA, but I also needed a little bit of money, and he gave me a job preparing grids, putting the Parlodian coatings on grids, which got me fascinated. I've always enjoyed working with my hands, making things, and electron microscopy was perfect because it had sort of the craft side in addition to using the instruments for the science side. So that was one of my experiences that I remember, and of course, gee, on a daily basis, being in Dick's lab was fantastic. I remember one day he told us that George Wald was coming. Well, I had never heard of George Wald as a graduate student. He said, oh yeah, he did the work on color vision. So I thought, this is going to be interesting. Dick was interested in neural anatomy of vision. He was looking at snails, invertebrates, and I was learning all kinds of things about vertebrates and frogs and amphibians, induction processes. Well, the next day, George Wald came. And I discovered that he had the Nobel Prize for color vision. And here I am sitting right next to a Nobel laureate. And, you know, I'm a first-year graduate student. I have no inhibition. So I asked him, what's it like to get the Nobel Prize? And for the next hour, he just told the graduate group around the table having coffee what it was like to win the Nobel Prize. I have never forgotten it. I think I'll have to live that experience through the example of George Wald. I don't think too many of us are fortunate enough to receive the Nobel Prize.
Absolutely. Could we back up just a little bit? I've looked at your CV, and I know that you went undergraduate to Abilene Christian College, and there must have been some connection, there must have been something that drew you to the University of California at Berkeley as opposed to some other institutions, or was it something as simple as a fellowship or like that?
You know, it was interesting. I was born in California, in Santa Monica, California. My dad was on the faculty at Pepperdine. He was a librarian at Pepperdine, so I always had kind of a connection to California. When I graduated from high school in New Mexico, I didn't quite know what I wanted to do. A bunch of my friends were going down to Abilene Christian. At the time, I was thinking I could be a competitive shot and discus athlete. I was very quickly disabused of that ambition. My freshman year, I went up against a shot putter named Randy Matson, and he ended up eventually being an Olympic gold medalist and world record holder. So I saw very quickly that I shouldn't do that. But I also had some instruction from my professors at Abilene in genetics. I had never taken a course in genetics and became very fascinated with genetic functions. How the gene, this was back in the early 60s, and you know, just a few years after Watson, Crick, and Wilkins. So we were just beginning to explore the double helix. We were just beginning to understand the molecular biology of the genome, and I was just filled with questions that my genetics professor also had. So he let me work in his laboratory. I learned how to reproduce fruit fly colonies. And he had me working on selecting the genetic mutants in fruit flies as a sort of a laboratory assistant for his course in genetics. And that, for me, was just a gateway to total curiosity. How in the world can you get an eye mutant that has no pigment? How can you go from wild type to this entire range of colorations in the eye? How do you change the morphology based on genetic expression? And we didn't have any answers. So I tried to think, what do I want to do with professional life? All of my friends were pre-med. And I thought, I don't really want to be a physician. I'm fascinated by it, but I really want to understand more about genetic expression, developmental questions. So I started shopping around to see what graduate schools had areas of my own interest. And California beckoned, you know, the birthplace. So I looked at Stanford, looked at Berkeley, looked at UCLA. Berkeley accepted me. Stanford didn't. I have always remembered that letter from Stanford. I had actually kind of wanted to go to Stanford, but I was so pleased to get into Berkeley. And those years were just fantastic in my education. My learning how to think scientifically, how to write like a scientist, express myself scientifically. I have never, ever regretted that transition from Abilene Christian out to Cal Berkeley. And it was an exciting decade for me. And the 60s were filled with social change for myself, professional, scientific maturation. I've looked back on that decade with great warmth.
Sure. You just spoke about friends being in pre-med. The Cal Berkeley situation is not a medical school. Yet your career eventually turned definitely towards medicine. Maybe you could tell us a little bit. I know you finished your degree, your terminal degree at Cal Berkeley. Maybe you could tell us about universities and institutions where you've held faculty or administrative positions as a result of your experience at Berkeley, and who may have had a particular influence on your career development in those venues.
When I was at Berkeley, I think my very first year started doing electron microscopy and getting into the literature. At the time, what we then called ultrastructure was very exciting, seeing parts of cells that had never been imaged before. No one quite knew what they did. And I needed to get a master's degree under my belt. I felt like I was, quite frankly, running fast at Berkeley. So I was working on a master's, learning electron microscopy, trying to understand cellular structure, function, taking all of the required courses. And I remember running across a paper by a fellow named Jean-Paul Revel, and it was published with Leonard Napolitano and Don Fawcett. It was on the ultrastructure of glycogen molecules. Well, skip 3 years into the future, and I'm looking for a job. I'm just about to finish my degree, and I'm thinking about postdocs. Norm Wessel's offered me a postdoc over at Stanford, but I thought I'd better back it up to see if I could find a job that would pay me something to keep me alive. So lo and behold, there was a brand new medical school, just a few years old, at the University of New Mexico back in Albuquerque, where I'd grown up. Didn't really think I wanted to go home, but as I thought about it, this job was in a medical school in contrast to a biology department, and I really wanted to do research. I wanted to spend most of my time during the day, evenings, doing research. So I accepted the position in Albuquerque at the University of New Mexico in this fledgling medical school. One of the reasons was Leonard Napolitano was there. Lynn turned out to be an incredible mentor for me, just as Dick Aiken had been in my graduate years. Lynn influenced me in ways that I did not anticipate at the time. But he was one of the major reasons why I went to the University of New Mexico. Johnny Ladman was there as the department head. He turned out to be an invaluable mentor for a young assistant professor. And for the next 28 years, I worked at New Mexico, developing some answers to the questions that I had and developing into an NIH-funded scientist. Worked with you for a while. You were a colleague over at the University of Arizona. We were both interested in matrix molecules and how those structures came together. You and I spent a lot of time talking about glycosaminoglycan structure and proteoglycan structure and what could we do to image those molecules in the extracellular matrix, and were the images real and what might make them artifactual. You and I had quite a few conversations during that period. So yeah, these are some of the people that influenced me. It was during that period that I met John Fallon. John and I developed a lifelong friendship and a professional association that resulted in a number of papers. We shared a lot of questions scientifically. And I went to his retirement last year over at the University of Wisconsin, but I don't think John will retire. He's still very active. He will always be curious.
Well, these are certainly some very influential people, not only in your life, but in many other lives. And you just brought up the name of Aaron John Ladman. And he indeed is one of the other individuals who is in the Living History Project, and one of your mentors, and you have now reached the same level of recognition, and I think that's to your credit.
Well, I owe John a great deal. Not only did he give me my first real professional job, he gave me some of the best advice I've ever had. He urged me to write for a Research Career Development Award, which I got, and that took me to the Hubrecht Laboratory in the Netherlands, and I thank John for that opportunity. He taught me how to run a department. John was the fellow who started getting me interested in higher administration. And I sort of inherited John's position when he moved on from the University of New Mexico to Hahnemann. So I owe John a great deal. He also put me on the editorial board of the Anatomical Record, taught me how to edit a scientific manuscript. I'm very grateful to John for the opportunities that he gave me and what he taught me.
And you mentioned that when you were at New Mexico and I was at Arizona, we were looking at interesting things in the electron microscope. I could see some fibrils and you could see some empty space. And you called yours mesenchyme and I called mine microfibrils, and we talked about those, and we had some very interesting days discussing how these things might possibly be inductive in the embryonic process. And those were good years, and years that I will certainly remember for a very long time. Tell us about how that led to your first, or maybe your most memorable publication at the University of New Mexico.
I'm not sure I have a single most memorable publication, but there are several that do stand out that answered questions for me that they were surprises. I think that's the best way to put it. Well, I worked for quite a few years on my doctoral work, and during that period I got very interested in what we now call cell signaling. Spemann, of course, determined the primary organizer as an inductive phenomenon, and we later learned that mesenchymal tissue and epithelial tissue influence each other in a variety of ways. And as immunology grew, we learned even more about cell-to-cell signaling. But I had always been kind of curious about what happened in embryos. You go from single-celled organism through multiple cellular organism, and pretty soon you have the foundation for not only shape, the morphology, the morphogenesis of an embryo, but you have the foundations of germ layers and ultimately basic tissues and then eventually organ systems. So I was very curious about the fundamentals there. One of the things that I was very curious about was, do cells actually touch one another when they're engaged in these inductive phenomena? And I'm not sure that I still have all of the answers to that. I kept thinking I would find contacts, some kind of a junctional specialization when an inductive layer came into contact with another. And yet I don't know why I thought that, because they are moving past one another, cellular movement, but it happens relatively slowly. When I first started asking these questions, I didn't know very much about surface molecules. We didn't know during those days, so I just kind of assumed that cells would touch one another and transfer something from one cell to the other. And very naively, I thought maybe cells could even transfer nucleotides. Ribonucleic acids would have signals, and I'm very naive, very curious in my naivete. One of the things that I do remember, and this came from work with John Fallon, we were looking at the apical ridge during limb morphogenesis, one of the more interactive tissues as we shape a limb. And to our very great surprise, we didn't see any gap junctions between the cells of the apical ridge at a certain very early stage before the ridge begins to thicken. In other words, as that ectodermal layer, those group of cells, stays relatively thin, there is some signal that induces them to thicken, and then there are a series of interactions that go back and forth between the inductive ectoderm and the also inductive mesenchymal cells below. Well, I got very curious about what does this apical ridge look like? So John and I fixed some tissues, various different stages, and to our very great surprise, at one point there were very few, if any, large gap junctions. I think we were doing this first in the quail. But as the ridge started to thicken, these junctions developed in the beautiful, beautiful circular intersections between lateral cell membranes. And we started wondering what in the world is going on, because as we watched the ultimate thinning and demise of the ridge after all of the inductive processes are more or less completed, the gap junctions disappeared. They went away. So there was a direct correlation between the presence and the development of these signaling junctions, these connections between cells, and the apparent time during which the ridge was most active in development. I've never forgotten that, because that was one of those gee whiz moments of what is this all about? And we published that. I think that went into either the AR or DB or one of those journals. And John and I are still kind of scratching our heads about that. We ultimately learned that those cells function like a syncytium. You can develop inject a dye. The dye will immediately go across the entire ridge. And I'm assuming the dye molecules are going through the gap junctions. I would assume that. But that was one of those surprise moments. There was one other. Okay. This one surprised me even more. When I was on my postdoc at the Hubrecht lab with that RCDA that I mentioned, John Blooming, a fellow that I was working with, and Ronald Decker, his postdoc, we were sitting around having coffee one morning. We were doing scanning electron microscopy, and we were trying to figure out why we were getting so much charging. We thought it was a shame that we had to put so much gold evaporation on the surface of those specimens, and what were we hiding? And I don't remember, one of the three of us said, wouldn't it be nice if we could just put more osmium into the tissue and use the osmium as the conductive element for electrons, trying to avoid that secondary electron emission. And I've forgotten again, someone suggested, let's do a ligand. And I thought thiocarbahydrazide might work. So I remember taking, with Ronald, we took a specimen, just out of curiosity, I think it was an amphibian tissue of some kind, and we fixed it, osmicated it, did the post-fix with osmium, rinsed all of that off, and then dunked it into thiocarbahydrazide with a buffer, and then stuck it back into osmium. Osmium, thiocarbohydrate, osmium. And lo and behold, those specimens came out just dense with osmium deposition. And we stuck it into the scanner, and it worked. It didn't charge. And we just thought, wow, this is a surprise. We published that. I think that came out in JUR, Ultrastructure Research, first paper. And to my very great surprise, of all of the papers that I've published, that one had the most science citation indices, highest number of citations, a technical paper. So these are the kinds of surprises that you do remember. They're memorable. I can go on and on.
And the conversations that we had were scientific and theoretical in nature, but when it comes right down to the practicality of it, scientists want to learn how to do something. And when you learned how to do the OTO method, I have to tell you why that is so well cited. It's because people want to know how to do something, and how to do something simple, clean, that works, and it works consistently. And that was, of the papers that I know that you've published, that has had the most personal impact on my personal research.
Oh,
and that was a remarkable paper.
All of us need lots of tools in our toolboxes.
Yeah.
And it was a privilege to be able to add a tool, a very efficient tool, into our collective toolbox.
Well, you've segued past some of the questions that I was actually going to ask you, and that's just fine. But now I'm going to ask you a little bit of philosophical information and ask whether or not, given this experience that you've had as a developing scientist, if you have any advice, if it were, for new researchers and new anatomists, if they are there, that are just beginning their careers. Based on your life and your experiences, do you have any philosophical kinds of advice that you could pass along?
That's a dangerous question, because it kind of opens up a Pandora's box of opportunities. I think the one thing that impresses me the most today, and all of us are dealing with a variety of different issues, political, economic, it's a challenging time globally today. And I think I'm watching something unfolding that I learned a long time ago, even when I was still a graduate student. I think human nature, as human beings, we are somewhat fascinated by the anecdote, a story. We're less fascinated by hard evidence. And as I see our political processes running their course today, and as I see candidates presenting their ideas and their positions, I find sometimes that candidates in the heat of the moment permit an anecdote to trump data, evidence. So I think going back to science for just a moment, I remember a story that Hans Bayman told. I don't remember him telling it, but I read about it. He was giving the Silliman lectures at Yale. And he told a story about an archaeologist who discovers the fragments of a vase. And he starts reassembling the vase. If that archaeologist starts whittling away at the fragments, if he tries to force those fragments together in ways that perhaps they didn't originally fit together, he's not going to get the truth of that vase. He's going to alter the evidence in such a way that what he gets is not going to be the truth. It isn't going to be the original. And he won't understand the shape and the texture and the colors of that original because they will have been altered. I think philosophically that's what troubles me now. And it's, I think, one of the biggest challenges. Not to misinterpret by changing the evidence that's in front of us. You ask your questions scientifically that address your hypothesis. You do your experiments. The experiment has to be clean. You've got to interpret the evidence that that experiment brings to you. And you can't let your anecdotal interests override the evidence. I guess philosophically that was a hard lesson for me to learn, but I've seen it again and again and again in virtually every element of our lives. Science, politics, economics, day-to-day. So I guess in answer to your question, maybe I'd seize upon that.
And I echo that. My PhD advisor was Frank N. Lowe, as you well know. And he told me there were two very important words in research, and that is repeatability and explainability. And if you can't do both of them, you probably don't have a piece of evidence that's worth the paper that it's written on.
You may not have the right answer,
That's
the correct
right.
answer.
Well, Dr. Kelley, you've been a textbook author. And your 9th edition of Basic Histology textbook with Drs. Junqueira and Carneiro has excellent reviews, has had excellent reviews, and is currently available in Kindle format from Amazon. Can you, or do you feel that you can share some of the memorable experiences in the development of textbook writing and how that fits into your career and how that piece became part of your...
Well, this was quite an honor that came my way. Junqueira and Carneiro were looking for an American author, and by a variety of ways, I was able to participate with them. John Long out at the University of California at San Francisco unfortunately passed away. He was their American author, and I was able to step in after John died. You know, working with Junqueira and Carneiro was quite a learning experience for me. Both of those fellows are very, very gifted writers, gifted teachers, and I learned from them how to develop a very simple wording in a textbook to describe some very complicated, complex biological processes. And I remember sitting across Luis Carlos's office down in Sao Paulo when I was down there working with him at one point, just marveling at how quickly he could go from an image to a paragraph or a revision of a paragraph in the textbook and have it very, very clear. And in our conversations, I began to realize that he was listening to how my thought processes would work. And then we would build that into creating a very clear paragraph, very simple, efficient paragraph that would address a biological process illustrated through either a light or an electron micrographic image. So that was an extremely good learning experience for me. Dick Aiken had taught me how to write scientific papers, and I learned how to translate that style into an educational style in a textbook from Luis Carlos. He was quite a mentor for me.
So that was a positive experience.
Oh, very much so, very much so. I enjoyed the process. I enjoyed the challenge of trying to teach through written processes. And it also gave me another layer of trying to bring more and more sophistication, more quality to one's work. And I'm very very pleased that that book has received so much use around the world. Those two authors went on after I decided to take my career in another direction several years ago, and they are still publishing, to the best of my knowledge, some very, very, very good histology textbooks, cell biology textbooks.
Well, as an electron microscopist and an extracellular matrix person, the first thing I did when I got a hold of your book was to turn to the chapter on connective tissue. And I have to tell you, it was absolutely beautifully written. It was understandable, it was clear, it was interpretable, and it was something that was put in a style that was memorable.
Well, like so many successful ventures, that was a team effort. And Juncker was also a student of connective tissue. And we had a lot of common ground. We had many very good discussions about how best to teach the cell biology of connective tissue.
Well, it came very clear in that text, and it was very good. Now, over the years of your career and mine, anatomy and particularly cell biology have changed immensely. And what we now know about cell biology is so different than it was in the 1960s and 70s. From your perspective, do you have any thoughts about what the future might look like? I mean, we've come a long way, baby, so to speak, and now we're at the threshold of some new departures. Do you have any thoughts about what might be out there in the next 10, 15 years for us?
Well, I think it's reasonably clear that as we've come to understand more and more about genomics, proteomics, glycomics, I still have a fascination with the genome. As we learn more and more about gene processes, gene regulation, gene function, I think we're going to learn more and more still about gene manipulation. We've called it engineering for the last decade or so. I'm fascinated by the conservation of genetic information, the things that separate Homo sapiens from Mus musculus, from a chimpanzee, for example. Very, very subtle, but very profound. I think we're going to come to a much better understanding of what makes genetic variation expressed in phenotype. I also think we're going to be able to see more and more therapeutic applications of genetics, understanding what we can do when we delete a gene or regulate a gene differently. I think we're going to see more. Part of the challenge is we can identify the genes, the gene segments, the fragments. Connecting them to a function is very challenging. But I think as we get more and more of an understanding of how certain genes and gene families impact health and disease, we're going to see a much greater ability to go back and change and alter some things at the genetic level that will have a therapeutic effect on those illnesses and those diseases. And I think the advances over the next 10 or 15 years there are going to be phenomenal. I also think we're going to understand a great deal more about the regulation, just biological regulation of the genome. It is fascinating to me how far we've come. Well, think about it. 40 years, 50 years since the discovery of the double helix, how much more we understand and how much more there is left to understand. And this is the beauty, I think, of cell and molecular biology, developmental biology. The questions that are infinite. I don't think any of us will be out of work. I don't think any of our curiosity will be effectively resolved. So this is the beauty of science. I truly believe it's infinite. There's so much to understand.
So much of it seems to have been impacted by the Genome Project. How do you see that project in terms of its impact relative to the double helix and the discovery of that, as you pointed out 40 years ago? Do you put those as similar kinds of impacts, or is one much more basic than the other?
You know, I think the thing that fascinates me the most about that early discovery of the double helix was the inherent nature and the simplicity, the elegance of the code. And I was thinking as you were asking the question, one of the things that fascinates me today that is similar to the fascination with genomics is the way our computer technology has evolved so rapidly. Coding for information, coding for messages. When you take a binary code, ones and zeros, the infinite, seemingly infinite number of ways that you can combine those pieces to get storage, processing of information, just like the nucleotides in the genetic code. And when I think about the applications for computer technology, information technology, to learning, to teaching, to systems management, to the expression of how we run our lives, it's very much similar to what it is on a biological level we're trying to understand more and more of in the genome. So I think the thing that fascinates me here is how these discoveries and these applied scientific events have impacted our lives in so many different ways. Obviously, we are what we are through our genome. But we function like we function through our IT in many ways today. I'm curious about what's next. Wish I could live long enough to see what that next major discovery that's going to be life-altering will be. That's the excitement of our science.
You and I have discussed many times that the most valuable thing that a scientist has is time. And as we get older and older and farther into our careers, we get somewhat even depressed, knowing that we probably won't live long enough to see what some of the real impacts of some of these things are. But I agree with you that the parallel development of the computer and the genetic code and the genome project and all that we are learning about genes and regulation, the parallelicity of those two very different scientific techniques might actually turn out to be fortuitously powerful in getting us to where we want to go.
There's a little bit of philosophy behind what you just said. I think those of us that have been active and curious and have been blessed with the ability to think clearly and productively, as long as we can keep those faculties as we age, I think we have a bit of a responsibility to continue to contribute. May not be the seminal scientific discoveries, but we can continue to address our curiosity and see how we can use the answers to that curiosity in an applied way to help our society, help our students. I think we continue to have a role. There is a wisdom that comes with experience. And I don't know that you're serving your society well, your students well, if you start thinking about the fact that you may have nothing left to contribute after a certain point. So philosophically, I think we can stay active as long as our faculties permit us, because we still have a great deal to contribute to each other.
I saw a sign the other day that said, "God, give me work until my life ends, and give me life until my work is done."
Good sentiment. Good
sentiment. Well, I'm going to change gears because we've been very positive here, and this one may be more difficult. What do you believe was the most difficult lesson that you had to learn in your career, not only as a scientist, but as an administrator and as a future consummate academician? What was the most difficult lesson that you think you had to learn?
You know, your personal life, your professional life, what it is that you do, have ups and downs. And I think the hardest thing that I had to learn was how to weather the downs. Professionally, you go through periods where nothing is working in the laboratory. You lose grant support. You graduate one of your best postdocs, and you go through a down period, and it's discouraging. It's depressing. It's hard during those periods to keep your enthusiasm, your confidence going. We all live in a very competitive scientific world. weathering those downturns, just like we have to weather downturns in the economy, downturns in the global societal environment. Individual lives of scientists have similar kinds of depressed periods. I think the hardest thing for me to learn was how to get through those periods, knowing that life is cyclical. There will be light at the end of that tunnel, so to speak. You will get your next grant. You will have more students coming along. You will have more productive times. You haven't burned out. I think that's one of the difficult times that I've been through and learned. And I experience the same thing now that I'm in university administration. There are periods of great frustration where you think, how do I get through this? This is depressing. This is really discouraging. But you learn that you will. You learn that you cannot give up. You just keep working at your ideas, your theories, your hypotheses, your challenges, and you find ways to work through them. And I think that's partly what comes with experience. You do learn that there are ups and down periods, and they are cyclical. And philosophically, you find ways to get through them.
Sure. I have to echo that completely. I just graduated my 13th PhD student who left my laboratory, and there's a hole and a gap in my laboratory at the moment, and it's quieter than it used to be, and we're in one of those cyclical down periods that you just described. But you can also look at them as challenge and as opportunity, and it's time to reflect, because you actually have a little more time to actually sit and think and look at the literature and say, boy, there's an idea.
You know, you're making a point that I agree with completely, and it took me a long time to understand this. The real joy and the satisfaction in science, and indeed any human activity, is the relationships that we build with other people. It's satisfying to answer a question. It's kind of ego-boosting to think for a moment that you're the only person in the world who knows this before you publish it. But the real joy is working with someone to get to that point. The exchange of ideas with another person, the challenges that another person brings to you, the joys of seeing a student mature under your tutelage. Those are the real things that I look back on. The postdocs that I've worked with, students that have gone on, John Nilsson, now the director of the Molecular Biology Institute out at Washington State. He and I have intersected through the years in many different ways. The satisfaction that I feel in being with John just as another human being is fulfilling.
Well, you've been the president of the University of North Dakota for more than 3 years now. Really changing direction here is, what is your vision for the institution, and what are your top leadership priorities for the University of North Dakota?
We've gone through a planning period, and we've put a name around it. We're calling it Exceptional UND. Embedded in the core of that simple statement is a commitment to higher education. Universities are about learning, and we come here to learn. Our students are here to prepare themselves through learning. Our responsibilities through teaching and learning with our students create the community that a university should be and is. To continue to enhance the quality of instruction, of teaching, of learning, to enhance the opportunities requires funding, requires facilities, requires that standards continue to be advanced and met, as we say, set the bar higher and higher. And this is my goal for the University of North Dakota. There is so much here, the faculty, the excellence of the faculty, the preparation that the students have in this northern Midwestern environment. They come through some pretty strong pre-undergraduate environments in their learning. They're very well prepared for the most part. We can capitalize on that preparation, and together with students, we can enhance the learning environment. And I think if you had to put this in very simple, concise terms, that's my goal for the university. The enhancement of our environment for learning. And we will do that through enhancing our facilities, our laboratories, our classrooms. We're bringing in more and more technologies into teaching and learning. There's a conference that's coming up in just a few days that will look at the intersection between the use of technologies and the different learning modalities that we have, and how can we synthesize these better on this campus. We're focusing on essential studies, essential learning. What must a student leaving the University of North Dakota be able to do and to have in their toolbox as they move out into an increasingly global society? So all of these packaged together will create an exceptional University of North Dakota, and I think long-term that's what we're going to work on together. How do we get more interdisciplinarity, more connections? How do we get more horizontal organization in addition to the vertical organization of our specialties on campus? How do we enhance our facilities? How do we gather more as human beings? How do we exchange these ideas? How do we enhance that learning environment using all of the activities that a university environment permits us to have? I think this is a very exciting time for the University of North Dakota. I have not met a single individual who has said, I don't want to participate in this. I want to stay in my own little world. I think the excitement of being able to engage in other areas. We've got people doing research on fabrics that will withstand space environment over in the aerospace programs, working with molecular coating engineering over in engineering. And we've got other people that are starting to look at the behavioral aspects of how do people intersect with the confinements of a spacesuit, as we do NASA-related exobiology on this campus. It's just an exciting time, and if I were a student coming into this environment, I would be so turned on, and if we can expand that environment, I just think the future of our university will be truly exceptional.
President Kelley, you're a consummate intellectual, and when I bring questions like this, you answer with great panache and aplomb relative to the intellectual growth of the institution. The general populace is interested in other things, like growth of the university, like Division I sports, like how much money is coming into the Alumni Association. Do you see those as distractions? Do you see them as cooperative adventures with the intellectual pursuits of the university? Or how do you see those things that the general populace of the city of Grand Forks and the state of North Dakota relate, who are not consummate intellectuals?
That's a great question, Ed, and I think in many ways this goes to the heart of our politics these days. I see all of these different functions as complementary. When you look at the entirety of a university and you look at the different revenue streams that come in to support the entirety of the university, when you look at the students entering that environment and you look at the gifts that they bring to us, many of our students are gifted in athletics. Many of them are gifted in having very high levels of competitive drive. That competitive drive can be expressed in graduate school or on an athletic field. It's the responsibility of the university to find ways to help that individual not only fit into society, but to expand their own abilities, develop their own abilities. So I see all of these activities as complementary. You know, athletics is interesting. For many, many graduates and for many people outside of the intellectual walls of the university, it is that athletic activity that provides them with insights into the workings of a university. They get to know the students. They express interest in the students because they're a very speedy back in the football team. If funds come in to support athletics as we move more into Division I FCS competition, as we have more and more success, that piece of the reputation of the university will be enhanced. We will be better known for student success in athletic competition. Many of those student athletes are getting MBAs. They have 4-point GPAs. One of our nose tackles last year tried out for the Pittsburgh Steelers. He's now working for the Vice President of the United States, and he's a Phi Beta Kappa. This is the kind of student that we deal with at the University of North Dakota. And it's, I think, part of the responsibility of the university to provide those opportunities, not just science, engineering, humanities. We have creative writing programs. Some of our creative writers are championship volleyball players. Yeah. So these are the kinds of things that I think all come together in an exceptional university environment. Politically, I think our community understands that. And as I talk to legislators across the state, they understand the value of the university. They're concerned about different things. They're concerned about sustaining the university system. We have an oil and gas boom going on right now. Their concern is 20 years from now, as we built our educational system, how do we sustain that in the event that we have a bit of a bust in our oil and gas industry? And I get that. I understand the reality of what they're saying. And as we try to level out the amplitude variation of ups and downs, I'm concerned too that we sustain the quality of our exceptional university going forward. And we do that through selective processes, guaranteeing multiple revenue streams, our research, our activities, our athletic programs, our grants, our contracts, our state appropriations, our tuitions and fees. All of these things come together to help us build an exceptional university.
At the risk of sounding over-complimentary, I have to tell you that in general, what I'm hearing at the public level is that your communication across the state is outstanding. And you're explaining this balance of intellectual and practical matters is reaching individuals not only in the eastern part of the state, but in the western part of the state, and that's certainly to your credit. And I want to compliment you on that. We're winding down, but I have to ask a question because you have not only administrative experience at the University of North Dakota, but at the University of Illinois, at the University of Wyoming, and certainly as chair of anatomy and cell biology at the University of New Mexico. And I wondered if you believe that your career as a scientist and a chairperson and an administrator in these other places has significantly influenced your decision-making processes and your administrative style as a president of an exceptional university.
Oh, without question. You know, what you see is sort of the sum of a lot of parts, a lot of experiences. I've learned a great deal at each of those institutions, and they have very different missions. They are managed and administered in very different ways. I would have to say that I've benefited from the experiences at every level along the way. And I think the biggest challenge for me right now is what's coming ahead. I wonder whether or not I would be helpful and useful in developing science policy at a national level. I've enjoyed my work with organizations in Washington. I don't know. You know, right now my job is to provide leadership for the University of North Dakota. But in time, what comes next? So I've tried to learn from every experience, every institution. The people at each of those institutions have brought different levels of experience and understanding of how business can be conducted, what works and sometimes what doesn't work. So I bring all of this to the present time and I start thinking, all right, 10 years from now, if I'm still intellectually alive, what can I do at that point? I may not have quite the energy to run a university. Would I have energy and intellect to write, to address science policy, to create in other ways? It's just part of trying to keep the continuum of life productive and useful to the folks that I'm working with.
Absolutely. If we could bring just a little bit of personal issues here. The First Lady of the University of North Dakota is a marvelous person. Marcia Bell Kelley has been a very big help to you, I believe. She certainly is a great ambassador for the University of North Dakota. Can you share at all how she influences or impacts what it is you do on a day-by-day basis?
You know, Marcia is a professional in her own right. She's a speech-language pathologist, has worked with children, adults, has many, many, many years of experience in clinical speech-language pathology. She was on the faculty with me at the University of Wyoming, and she and I formed a sort of a professional couple down there, her and her teaching, and I and being the dean of the college. Marcia is probably our most productive volunteer here at the University of North Dakota. In her graceful, social way, she has connected, I think, with as many people in North Dakota as I have in her role as First Lady. She, through her own experience and her professional life, is able to interpret the university to our communities around the state in a very effective way. And her personal manner is just as gracious and as welcoming and approachable as anyone could hope for. And she's my best advisor. Late at night, early in the morning, when we're having coffee, we sort of think about what's facing us and how do we together address some of these issues. And I'm very blessed to have her as a partner in not only life, but in this professional activity that she and I are both engaged in. I can't think of another person that would be as effective for the university and for me as Marcia has been.
She's an outstanding person. And finally, President Kelley, do you have any unfulfilled aspirations that you are immediately working on or have out there in the next strategic plan that you can share in the next few minutes?
You know, I say this not entirely facetiously. Marcia grew up in the North Shore area, the Iron Range, and she introduced me to the North Shore of Lake Superior. Up towards the Canadian border, there's a town called Grand Marais, and they've got an old folk school up there where they kind of carry on some of the old traditions of wooden boat building and toll painting and all different kinds of crafts. I've got sort of an unfulfilled ambition of learning how to work with wood. I took a course in shop when I was in junior high school, and I still remember it, I had great enjoyment in turning things on lathes. The effect was immediate. You could craft, shape, and it was almost immediate, very satisfying. Not like today, where sometimes at the end of the day you have nothing to touch that's real. So one of the things that I think I would like to learn to do is woodworking, furniture making, and sort of stimulated by watching some of these fellows building these wooden boats up at the folk school in Grand Marais. I'd also like to try my hand at writing. I mentioned science policy a moment ago. I think writing is very challenging. It doesn't come easily for me. I'd like to see if I could do more in writing, not necessarily science writing. My dad was a storyteller. I kind of wonder what's in me in terms of writing out some of the stories that I remember from my father. Just a personal thing, but I'll put that off for a few years. I've still got a lot to do right now.
Well, this has been a very enjoyable time for me, and I thank you, President Kelley, for sharing your thoughts with us. Clearly, you stand as an icon in the anatomical community, and your career is an inspiration to all of us, but most particularly to the new young anatomists who may well aspire to administrative positions and achievements that are well beyond their careers as outstanding instructors and scientific investigators. Thank you for an outstanding hour. It's been great to visit with you.
Well, Ed, thank you for the opportunity. It was great working with you in the 70s, and it's great working with you now, too.